Good evening, everyone. It is once again Ted the Speed Learner, and tonight we're going to cover the topic of floating gate. Okay? The story of the floating gate begins with the biographies of two gentlemen. The name of the first gentleman is Jack A. Morton. He was born in 1913 in St. Louis, Missouri. I'm sure at this point you are speculating whether Jack Morton was related to the inventor of Morton salt. So, if you're speculating that, I'm going to go ahead and give you some information about that. In case you were curious, feel free to take the time to research the name of Joy Morton. That's because he was the inventor of Morton salt. Since the Morton Salt Company was founded in Chicago, Illinois, I suppose it is entirely possible that Joy and Jack Morton are somehow related. And you'll find that out in due time. You are more than welcome to leave me a comment if you decide that you want me to research this topic, because I'll be more than happy to do that for you. But at this point, I'm going to return to Jack A. Morton. He was raised in St. Louis, Missouri, and he attended Wayne University, located in the state of Michigan. Mr. Morton earned a degree in electrical engineering at Wayne University. He also earned a master's degree in engineering at the University of Michigan. After Mr. Morton earned his degree from the University of Michigan, he was employed by Bell Laboratories. Shortly after that, World War II began. Mr. Morton then developed a microwave amplifier circuit that extended the range of military radar systems. This technology assisted the Allied forces in World War II when they were fighting the Japanese in the Pacific Ocean. Of course, World War II finally came to an end. But what was Mr. Morton's next project? Well, he developed something called a vacuum triode. Now, what in the heck is a vacuum triode? You can research this for yourself if you want, but I'll try to explain it as best I can. Now, before I tell you what a vacuum triode is, I actually have to tell you what a vacuum diode is. A vacuum diode has a cathode and a I guess it has diode. I was thinking it had an anode, but whatever. A vacuum diode converts alternating current to direct current. But what if you wanted to amplify the voltage of a vacuum diode? Then you would have to add an additional electrode. When you add when we add an extra electrode, you create a vacuum triode. Mr. Morton developed the vacuum triode. Okay? Bell Labs used the vacuum triode to amplify electromagnetic waves. In previous videos, I covered various details about electromagnetic waves, but I will provide a few more details in this particular video. Alright, before I continue, I need to explain what a magnet is. Did you know that a copper wire can be turned into a magnet? If you now, what you want to do is you'd want to attach like a wire. Say you had this little thing right here. You wrapped it around with a copper wire. Okay. So, if you were to wrap a copper wire around a metal piece, this is not a metal piece, but if you had a metal piece, you'd wrap a copper wire around it. Okay, you could actually turn that into a magnet. Okay. So you'd attach one end of the copper wire to a battery anode and the other end to a battery cathode. Okay? Then electrons and current would flow through the copper wire. Electrons would go in one direction and the current would go in the opposite direction. If you wrap the copper wire around an iron pipe, then the copper wire will generate a magnetic field. The strongest part of the magnetic field, which is created by the current flowing through the copper wire, can be found in the center of the wire. Keep in mind that an electromagnet can generate an alternating current. All you have to do is change the amount of current traveling through the copper wire. Now you should have a basic understanding of an electromagnet and alternating current. But how does this relate to Mr. Morton? Well, Mr. Morton didn't just create an electromagnetic current. Mr. Morton had created a vacuum triode that was generating electromagnetic waves. The vacuum triode that Mr. Morton created was able to amplify microwave signals. This technology enabled the American Telephone and Telegraph Corporation to create a transcontinental microwave relay system. This enabled television companies to transmit television signals across the United States as well as to other nearby nations. But what does any of this have to do with a floating gate? After Mr. Morton completed his research on the vacuum triode, he started researching the recently developed point contact transistor. That's because one of his employers, Mervyn Kelly, insisted that he perform this research. The point contact transistors were unreliable and easily malfunctioned, but Mr. Morton and his team of engineers developed more reliable transistors. Two members of this team, which was Eugene Anderson and Robert Ryder, worked closely with Mr. Morton. They developed transistors that could amplify signals and transistors that could switch applications. One particular transistor could generate a tone to indicate a long-distance telephone call. But before I continue this discussion, I have to discuss the contributions of yet another person. The name of this person is Gordon K. Teal. At the time, point contact transistors were using germanium. But germanium at that time was called a polycrystalline. It was a polycrystalline material. As you should well know by now, the prefix poly means many, and the Latin word crystallis could mean ice or any clear material, specifically a clear mineral. If you look at a photo of a chunk of germanium, you will see that it isn't as clear as a diamond is. Part of the reason for this is that chunks of germanium aren't clear due to the fact that they contain small amounts of copper. So your germanium contains small quantities of copper. Okay? So Mr. Teal, in whatever process he did, he grew a single crystal germanium to prevent the germanium from collecting copper contaminants. This improved the performance of the point contact transistor. If you look at photos of single crystal germanium, you will see that these crystals are just as reflective as mirrors are. Feel free to read these web articles for further information. I've included some links down here in the comment section below. Mr. Teal began to work with a gentleman by the name of Morgan Sparks. They developed a double doping technique. Now, what is a double doping technique? That's a topic for a future video, but if you want to research it for yourself, go ahead. In 1952, Mr. Teal resigned from the Bell Bell Laboratory and started working for Texas Instruments. Now, at this point, I have to state that I'm not an expert on modern-day computer electronics, but I'm presuming that single crystal germanium became the first floating gate. And I'm also going to presume that the silicon wafers eventually replaced the single crystal germanium in modern-day floating gate transistors. I will probably revisit this topic in a future video. Alright, I want to thank you very much for tuning in. I will tell you more in a future video, so I'd like for you to stay tuned.